Hello, guys. Welcome to Romta Solutions and welcome to grade 10 electric circuits. We are still dealing with past papers. So, this question is about 16 marks. When you do this question, you must spend about 16 minutes. But of course, this video will be longer than that, at least, maybe, let's hope, because I have to explain as well. All right? Okay, cool. So, now let's talk. Now, we are saying, they say, consider the circuit below. The bulbs are identical. Ooh, interesting. The resistance of the battery, ammeter, and connecting wires can be ignored. Oh, cool. They have negligible resistance. Cool. 3 cells transfer 90 degrees, transfer 90 joules of energy to 20 coulombs of charge. Define the term voltage. What is voltage? So voltage is simply work done per unit charge. Okay, so voltage, okay, let me write it here. It's work done per unit charge. All right, it's work done per unit charge. Okay, now calculate the voltage of all 3 cells. Interesting. What you know, they have given you the work done, energy transferred, and they have given you charge. You guys know that voltage is work done, which is energy transferred as well, right? Energy transferred per unit charge. So what is the energy transferred? It's 90 joules. What is the charge? It's 20 coulombs. So what is this? 90 divided by 20 must be 4.5, I believe. So this is 4.5 volts. The voltage of all 3 cells is 4.5 volts. Okay, cool. So, what would the potential difference of each cell be? There are 3 cells. Therefore, V of each cell will be 4.5 divided by 3, which is 1.5 volts. All right, so each cell will have the potential difference of 1.5 volts. Okay, perfect. Now we then need to go to the 7.2, and I'll have to write this information in the next page. A charge of 10 coulombs passes a point in the main circuit in 40 seconds. 7.2.1. Determine the ammeter reading in this circuit. Okay, let me go back to my black writing. 7.2. They said the charge is 30 coulombs and the time is, or is it? The time is 40 seconds. The time is 40 seconds. Okay. 7.2.1, determine the ammeter reading in this circuit. Okay, cool. When they say ammeter reading, they mean we must find current. Okay, they mean we must find current. So what is this? This is 30 over 30 coulomb over 40 seconds. This will become 0.75 amperes. You have a calculator, please confirm. But of course, it is 0.75 because it's 3/4. It's 0.75 amperes. Okay. Now, determine the effective resistance of the parallel combination of resistors. Okay. Now, this is very interesting. Okay. This is very interesting. Guys, hear me out. We're looking at the effective resistance of the parallel combination. We have the current flowing through these guys. Okay, we have that current. Now, for us to be able to calculate the effective resistance, we also need potential difference at least, or we need the resistances. But in this case, we do not have the resistances. But I can tell you, what we have is we have the the total potential difference. Okay, we have the total potential difference. So 7.2.2, we know R equals V over I. The R that we need to use is the one that we're looking for. The V that we need to use is the V that is supplied by these guys. Remember, we were able to find the V supplied by these guys. Now we also know the current flowing in the circuit, right? We know the current flowing in the circuit, so we need to find the resistances. So this will be, what was the potential difference? It was 4.5, I believe. And what is the current? We just solved it. It was 0.75. Let's see. 0.75. Oh boy. 4.5 divided by 0.75. This means the effective resistance is 6 ohms. Okay. This means the effective resistance is 6 ohms. Okay, it is 6 ohms. Okay, so we are cool. The reason I use that formula as it is because we don't have any other resistors connected in the circuit. We only have this parallel combination. Okay, we only have this parallel combination. 7.3. So 7.3, let's go. 7.3 says, if one of the light bulbs burns out, how would the brightness of the other two bulbs be affected? Right? Only brighter, dimmer, or no charge. So, what we know, the potential difference is still the same. However, when the current, when one of the resistors burn out, what it means is that the total resistance will, remember, to burn out means it's removed. So that means the total resistance will increase. Now, if the total resistance increases, what happens? That means your current will decrease. Now, if current decreases, that will mean that the brightness must also decrease. Remember, power is basically related to potential difference in current. All right. Now, potential difference is the same. However, and by the way, power is directly proportional to potential difference, and it's also directly proportional to current. Potential difference is the same because they are resistors connected in series, but current has decreased because total resistance has increased. So since current has decreased, it means brightness must decrease. So if brightness decreases, that means they will be dimmer. Okay, so our answer is they will be dimmer. Okay, they will be dimmer. Now briefly explain your answer to 7.3. When it comes to these explanations, I like saying, guys, you are not the one who said the question paper, and also similarly, you are also not the one who wrote the memorandum. Just give reasons that make sense to you. As for how long they are, make them shorter, but let it have order. For example, I'm going to show you now. When one of the resistors burn out, the effective resistance increases. Right? Increases. R is indirectly proportional to I. R is indirectly proportional to I. Current will decrease while potential difference is constant. While potential difference is constant. While potential difference is constant. Right? While potential difference is constant. Therefore, brightness will decrease. Therefore, brightness will decrease therefore brightness will decrease. Hence, the bulbs are now dimmer. Right? So, you see, this part, guys, we only explain it like this on the surface because you haven't yet done power in grade 11. Okay? I mean, in grade 10, you're not doing power. You will cover power in grade 11. But again, I will urge you guys, next time you go to the stores, I want you to look at your light bulbs. You will realize that some have 9 watts, 10 watts, 8 watts. I'm talking of your LED lights. And if you can also have access to those old bulbs, you will realize that some are 60 watts, some are 80, some are 100. And those with 100 watts are brighter than those with 60 and 80. Okay, so the greater the wattage, the greater the brightness. Okay, so these reasons are what we can give so far for grade 11. When one resistors burn out, effective resistance increases. We know R is indirectly proportional to I. So therefore, current will decrease while potential difference is constant. Remember, we're referring to the total voltage. Therefore, brightness will decrease. Hence, the bulbs are now dimmer. With this, you get all your 16 marks. And that last question of the reason, you get your 2 marks. I don't know what they will mark, but you will get all your 2 marks. Okay, as you can see, there's an order here that helped you to come to the point of why are they dimmer. So with that being said, it's a wrap, guys, and to believe that you have enjoyed the lesson. So